Welcome. Today we're exploring the Model Context Protocol architecture, the foundation that securely connects AI applications to context sources. MCP follows a client-server architecture. An MCP client connects to an MCP server through a dedicated connection to obtain context data. There are three key participants in MCP architecture. First, the MCP host, the AI application that coordinates everything. Second, MCP clients, components that maintain connections and obtain context. And third, MCP servers, programs that provide the actual context data. Let's see this in action with Visual Studio Code. VS Code acts as the MCP host. When it connects to the Sentry MCP server, the VS Code runtime creates an MCP client object to maintain that connection. When VS Code then connects to another server, say the local file system server, it instantiates an additional MCP client object. Each connection gets its own dedicated client. Here's the complete picture. The MCP host sits at the center, managing multiple MCP clients. Each client maintains a dedicated connection to its corresponding MCP server. This architecture allows the host to access multiple context sources simultaneously, whether that's a file system, a database, or a remote service like Sentry. Now, here's an important distinction. MCP servers can run locally or remotely. Local servers using STDIO transport like the file system server typically serve a single client and run on the same machine as the host. Remote servers using streamable HTTP transport, like the Sentry MCP server, run on external platforms and can serve many clients simultaneously. And that's MCP architecture. A flexible, scalable system connecting AI applications to the context they need. Want to learn more? Visit the Model Context Protocol documentation. Thanks for watching.